This is part 2 of solving systems of equations. We're on example 3, solving a nonlinear system by substitution. For this one, we have x squared plus x minus y equals -1, and we have x plus y equals 4. So the first thing you should do, if you're going to solve using substitution, evaluate which equation will be easiest to solve for. And we can see the linear equation would be easiest to solve for. You could solve for x or y quickly. If you solve for x, you're going to have to substitute in twice, and this one is going to be squared. If you solve for y here, you're only going to substitute one time. So by looking at this, you can quickly evaluate that it's best to solve the second equation for y. So let's do that. Y equals, all we have to do is subtract x from both sides. And then we know that y equals this right here. If we know that y equals -x plus 4, we can substitute that into the first equation. So we're going to leave the first equation exactly like it is. X squared plus x, and then minus y. In place of y, we're going to substitute what y is equal to. So y is equal to -x plus 4. All right, so it's important to put that in parentheses because you see that in the equation, it was x squared plus x minus y. So I have to minus 1 times everything in your parentheses here. So I'm going to have x squared plus x, -1 times -x is plus x, and -1 times +4 is -4. All right, so I can combine like terms. I'm going to have x squared, 1x plus 1x is 2x, and then minus 4, and that equals -1. Since this is a quadratic equation, I'm going to set it equal to 0 by adding 1 to both sides. So if I add 1 to both sides, -4 plus 1 is -3. When I set it equal to 0, that means I can now factor and solve it like any quadratic equation. So I'm going to have x times x, what multiplies to give me 3. 1 and 3, I need a plus 2, so my bigger number gets the plus. So I'm going to have x minus 1 equals 0, x plus 3 equals 0. Add 1 to both sides, x equals 1. Subtract 3, x equals -3. So we're going to have two solutions, 1 and -3. Now, to find the y value, I have to plug these in, okay? So this is probably going to be one where I have two solutions, but I have to plug in these one at a time. So I'm going to plug in 1 first. So let's plug it into the second equation. So it's the easiest. So we're going to have 1 plus y equals 4 minus 1, y equals 3. All right, so that goes with my x is 1. So 1, 3 should be a solution. And then we're going to plug in -3 as well. So let's do -3 plus y equals 4. Add 3. Y equals 7. So -3, 7 should be another solution. So we can quickly check that by graphing. All right, so this one I'm going to have to add 1 to the other side. Well, let's first rewrite it in the correct form. So let's put bring y to the other side. It's going to be y equals, and it's going to be x squared plus x plus 1. All right, so this equation here is equivalent to this one. All I did was add y and then add 1 to the other side. So I just rearranged it by moving a couple variables, or a variable and a constant. All right, so I'm going to have x squared plus x plus 1 And then I'm going to have negative x let's see, use the wrong negative. Let's see. Negative x plus 4. And I'm going to hit graph. And if I did this correctly, the intersection points should be at negative 3, 7. So here's negative 3, 7 and 1, 3. So it does look like those are correct. We can check the table of values again just to make sure. 1, 3, 3. Those have the same y value, so that is correct. That is a solution. Negative 3, 7. Negative 3, 7 is also a solution. So that's a way to check it quickly to make sure that you did it correctly. But this is how you would solve a nonlinear system using substitution. Example 4, solving a nonlinear system by elimination. All right, for this one you can see that we have 2x squared minus 7x minus y equals negative 4. And we have 2x plus y equals negative 9 as our second equation. So we have a quadratic and we have a linear equation. So we have two equations and we're going to solve by elimination. Elimination, remember, is where one of the variables goes away. This one is already set up to eliminate the y's. So if we add these two equations together, we're going to get 2x squared. Negative 7x plus 2x is negative 5x. The y's eliminate. And then negative 4 plus negative 9 is negative 13. All right, now we can set this equal to 0. We have a quadratic, so that's what we always want to do with a quadratic. So I'm going to add 13 to both sides and set it equal to 0. All right, now I could try to factor this, but I'm going to look at this and say 2 times 13 is 26. So my factors are 1 and 26, 2 and 13. 3 doesn't go into it, 4 doesn't go into it, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't. So this one is not going to factor, or at least not easily. So what I'm going to do is use the quadratic formula. So I know that A equals 2, B equals negative 5, C equals 13. So I'm going to have X equals negative B, negative 5 is 5, plus or minus the square root of B squared, negative 5 squared is 25, minus 4 times A times C. And all of that is over 2A. All right, so I'm going to have X equals 5 plus or minus. So let's pull up our calculator here and see if we can quickly do this. All right, so I'm going to have 25 minus 4 times 2 times 13. And this is actually called the discriminant. The part underneath the square root is called the discriminant. If that's positive, remember from Algebra 1, if the discriminant is positive, that means you have two real solutions. If the discriminant is 0, you have one real solution. If the discriminant is negative, you have no real solution. So we got negative 79. So that's the square root of negative 79. And 2 times 2 is 4. All right, because this number is negative, that means we have no real solutions. All right, so this is a quadratic and a linear. This is a circle and a linear equation, but it's basically the same thing. No real solutions means, in this case, that the quadratic and the linear equation do not touch in any form. So no real solutions. There's no points in common. If it touched at one point, it would be one real solution. Again, if it goes through, if the line goes through the circle, the parabola, whatever equation you're looking at, it would be two real solutions. So again, example 4 would have no real solutions. If you want to check yourself, set each of these equal to y, plug it into your calculator, graph it, and you should be able to see the graph where they do not intersect.